This demo is part of the Work Package 4 of REWIRE, in which we use Keystone, an open source framework to build TEs in RISC-V architectures, and extend it to provide new key functionality. One of these functionalities that we are providing are the secure software updates that we are going to discuss in this demo. In general, trusted execution environments are designed to protect data in transit, that is, while this data is being used. And if one looks into designs such as SGX, they assume that once the enclave has been built with a particular version of the code, it never changes. And one can see this, for example, if they look into the attestation service they provide. This attestation service is based on the hash or the identifier of the enclave, and this is assumed to be constant. Also, all the services that they provide are based on this information. If the identifier of the enclave, that is the code of the enclave, changes, then some of the services are not accessible again by any of the enclaves that are derived from this one. If one considers the software development lifecycle, this approach of SGX, for example, goes against the well-known software development lifecycle that has improved the security of different applications by periodically going through a cycle in which applications are analyzed, designed, implemented, tested, deployed, and once something happens or they require some maintenance, the cycle starts again. Therefore, the secure lifecycle management of a device requires a secure update mechanism, which allows an enclave to be updated and its state or data to be transferred to the following versions without breaking any of the security guarantees that the enclave system is providing. As mentioned before, the maintenance is one of the key parts of the software lifecycle. This is basically because security issues in software are discovered on a regular basis, and also different bugs that the programmers can introduce in their own code. Usually, one solution is to just roll out a patch or an update of the enclave and applying this patch to the software. If one looks into commercial TEs such as SGX, they do not allow the update of the enclave, but they still allow some sharing of the data or the state if the developer of the enclave is the same. And then all the enclaves developed by the same developer will have access to that data, regardless if there is an older or a previous version of the enclave. However, designing a software update mechanism that fits the enclave threat model is not straightforward. Such a mechanism has to prevent, for example, rollback to previous versions of the enclave that has been deemed insecure. And this also implies that any attacker is not going to be able to exploit the bugs reason why this version of the enclave was labeled to be insecure. Also, they need to provide state synchronization between the previous version of the enclave and the new version of the enclave that is being applied. And additionally, they have to provide strong evidence that the update has been applied, has been installed correctly, and has been installed to the version that the developer actually wants to be installed.